Okay, we're on our next installment of 6.1. We just finished talking about discrete random variables. Now let's talk about continuous random variables. These are going to be very simple because it's very similar to something we've already done. Now a continuous random variable takes on all values within an interval. There are no gaps between them. The probability distribution of a random variable x is then going to be described with a density curve because of this. So it's not just a histogram anymore, it's now a curve. The probability of any event is the area under the density curve and above the values of x that make up the event. Does that sound familiar? Now, intervals of values are given a probability. However, the probability of any individual outcome is 0. Okay? Now, that's because continuous random variable is not defined at specific values. Since it can be literally any infinite number, the chance of getting one particular number as an outcome is almost impossible. So that's why we would do on an interval. Okay? Hopefully this is looking familiar. It looks similar to z-scores and normal distribution calculations. That's going to be how we calculate our continuous random variables. So let's go through one quick example. The height of young women can be defined as a continuous random variable, and they're calling this one y, so that could be instead of x, with a probability distribution that is normally distributed with a mean of 64 and a standard deviation of 2.7. Now, what is the probability that a randomly chosen young woman has a height between 68 and 70 inches? So it's written this way, and we're going to use normal CDF. Okay, now the only thing here is you want to make sure everything's labeled. So your lower value, your upper endpoint or value, whatever, your mean, and your standard deviation. And you get 0.56 or 56%. So, or 0.56. Sorry, there was a typo. 0.056. So about a 5.6% chance that a randomly chosen young woman has a height between 68 and 70 inches. All right, now I want you to try these. Pause your video and see what you can do. So we're looking at the weights of 3-year-old females. They follow a normal distribution, which is has a mean of 30.7 pounds, standard deviation of 3.6 pounds, which is interesting. At the time that I'm making this video, my son is about a year and a half old, and he's already 27.5 pounds. So I just find that interesting. We want to find probabilities that they're at least 30 pounds, between 25 and 35, and then we want to find the weight that gives you 80% chance of being less than that value. So we're doing normal CDF for the first two. But for that last one, it's a little bit different. This is when we would use inverse norm. So you want to find the random variable that corresponds to 80% or 80th percentile, if you will. So that's when you use inverse norm. Again, make sure you label each of your outcomes if you're using this calculator speak. The other option for doing this is actually calculate the z-scores by hand. So for instance, for this first one, we would do 30 minus 30.7 divided by 3.6. That would give you a z-score, and then you would use that to either look up in table A or then use normal CDF, but for the standard normal curve. Okay? That is it. That was a short little end to this section. Hope everything makes sense. If you have questions, obviously ask me. There's always more practice in the book, too, if you need more practice.